On part 2, Trig ID number 15, we are probably going to press through to 23, so hopefully there's not a part 3, but if there is, please don't have a conniption. Alright, I was wondering, what is the relationship between sine of an angle, sine of theta, and sine of a negative angle? So are they equal? Is one the opposite of the other? So peeking at a sine curve, let's say we go out a certain amount, say I don't know, some theta. We'll just go out this amount and we'll say, oh, that's the angle theta. So what is the sine of theta? Since this is a sine curve, we know the peak is 1. But this one is going to read it. You take the value of the angle on the x-axis, go up or down and reach the line, and then read its value on the y-axis. So I don't know what that is. Say it's 0.8. It's not quite 1. Alright, so sine of theta is 0.8. So if sine of theta is 0.8, what's sine of negative theta? So what if I go out the same but in the opposite direction? Here, say that if that's theta, and we can pick any distance as long as we go the same distance from the origin in the opposite direction for negative theta. This time I go up or down to reach the graph. I hit right here. This lowest point I know is -1. So it looks like they're the same number but the opposite sign. So sine of theta and sine of negative theta are not equal. If I put an equal sign, because just like 0.8 does not equal negative 0.8, but they are related in that one is the negative of the other. So I could make this an equality by either putting a negative sign here or a negative sign here. So it'd be kind of unbalanced putting a double negative, a negative in front of a sign with it. Those would not become a positive, but this looks more balanced if I put a negative sign here. So that's a trig ID. So anytime you find a negative in the argument, this is the argument, that to which the function is applied is called the argument. If there's a negative in the argument, and it's a sine curve, it can pop out in front like that. So that is a trig ID. So on number 16, we're going to do the same thing with the cosine. How does cosine theta relate to cosine of a negative angle? Can you do the same kind of evaluation that I just did? This time we need a cosine curve. All right. Alright, even a rough one, we know it's going up to 1 and down to -1. And if we go out a certain amount theta in one direction, how does that compare if we go out the same amount theta in the other direction? If we stop right here and read the value, I don't know, 0.7, and we go negative theta this direction, we can't go down and hit the curve, we also go up and hit the curve. I didn't draw mine very clear to make this point, did I? This is supposed to be a symmetrical curve. That's even worse, I think. But you go out and hit the curve, and look at that. Lo and behold, they're the same point, no matter which way you go. Because the cosine curve is like this, we can say that cosine of theta equals cosine of negative theta. So if you go out this amount, you hit the curve at the same point that if you would hit it going in the negative direction. Alright, so that's number 16. These are equal. They weren't opposites like they were in the sine function. So whenever you have the cosine of a negative theta, you can just drop it because it's equal to the cosine of theta. And the next trig ID is going to evaluate tangent in the same way. I'm wondering if they're equal tan of theta and tan of negative theta. By examining the curve, I'll just give one period of the tangent curve. And the tangent curve looks like this. So if I go out theta this direction, call that theta, I would get the value here. And if I go out theta in this direction, it's negative theta, I would get the value. Again, it's hard to tell from my hand-drawn graphs. I'll draw it more symmetrical. Alright, see if this makes my point. If I go out negative theta in this direction, I go out negative theta, I come down and hit the graph, and I read it over here. So tangent of theta was up, negative. Tangent of negative theta was down the same amount. So it works like the sine curve. They're not equal unless I put a negative sign in front of one side or the other. So this trig ID allows me to pop out this negative sign in front of tangent like I could with sine. Alright. The last three look like this. If I have sine squared of a theta plus cosine squared of theta, I was wondering what that equals. So let's pull out our ABC right triangle and look at it. So here's theta. Sine is opposite over hypotenuse. That quantity is squared because I'm looking at that squared. Cosine is going to be adjacent over hypotenuse squared. So I was wondering what that was. So algebraically, let's do the math, do the algebra. So when you square a fraction, you square the numerator and the denominator. And when you square this fraction, now notice the denominators are alike, so we can put it over a common denominator. And I just, for aesthetics, I'll put the a squared first and then the b squared. So what is a squared plus b squared though? According to Pythagorean theorem, it does equal c squared. So I can substitute a c squared in for that, and that is nothing but a big fat 1. So our trig ID number 18, sine squared plus cosine squared equals 1. Alright, number 19, we'll use the same triangle, and we'll do 1 plus tangent squared. So evaluating that, we get 1 plus tangent is opposite over adjacent. I'll go ahead and square each of the numerator and denominator. Now I can write 1 a squared over a squared and give them the like denominator. So then I get a squared plus b squared over a squared. And a squared plus b squared is c squared. C squared over a squared. C over A. What is that? In our triangle, C over A, what trig function is that? Hypotenuse over adjacent. It is secant. So I can go back here and say C over A squared is secant squared. When we square a trig function, the square turns out here. This means secant theta squared, but we write it, to be cool, we write it here. See how I wrote it here and here and here. So 1 plus tangent squared is secant squared. Alright, in like manner, show me with the triangle, show me with the triangle what the 20th trig ID will equal. I'll tell you tomorrow if you would just go ahead and use the triangle and tell me what 1 plus cotangent of theta is. So that's your work for tonight. Find out what the 20th trig ID is by setting up the triangle using this triangle right here for it. Alright, so I was able to do this in 2 parts, and we will be using these trig IDs tomorrow to simplify expressions by substituting these trig IDs in and using factoring usually. So I'll take an expression like this, and the command will be simplify. So when you're asked to simplify this, I don't see any trig IDs from the big 20 that we did, but if I factor out a sine x, I do see one. So cosine squared minus 1 is just another version of this one. Because if I move cosine squared by itself, sine squared would come over here and be 1 minus sine squared. And cosine squared, if I keep it by itself, I keep sine squared by itself, cosine 1 minus cosine squared equals sine squared. So I can substitute sine squared in here and get sine cubed. Alright, we'll work on that tomorrow. That's the direction we're heading in. Till then, over and out.